have a request for you, sir.
Please tell me.
Sir, actually, in the hostel, there is a lot of connectivity issues. So, like, if there is a 50-minute class, out of that, only 20-30 minutes we are able to hear you and watch your screen. And other time, we are not able to see and understand. So, we request you to record those videos and provide that on YouTube, or that provide us on the WhatsApp groups, like Sachin Vivaris sir has done.
Uh, to be honest, I do not know how that is done. Let me get in touch with some faculty and I will learn and I will do that.
Is it
Yes,
difficult
because
for us? Yeah.
So you could just simply share the PPTs so that we could read it side by side.
yes, that I can do. That is not a problem. Regarding the stresses and ship structure, did you get the PPTs?
Yes, sir.
Okay, so that is done. This one also I will share it with you. Okay, let me
Okay, sir.
just see. Let me just see. Okay, I will share this PPT. Everything that I show you will be shared with you. There is no doubt in that. But I have to filter out some data out of it. So let us do one thing. I will not share it with you now, but within one day I will start sharing all the PPTs with you. Okay, is that okay?
Yes, sir.
And regarding today, is your connectivity all good now, or you are still facing issues?
Right now it's working. Can't say of future,
It's all
sir.
right, sir.
10-20 minutes.
Okay. I mean, I thought hostel internet is good because less number of students are there. I thought it will be fast. Okay. Uh, okay, let me see what I can do about it. Okay. But all these PPTs and everything, whatever I'm showing you, I will be giving it to you. So do not worry about that. Only thing is, as of now, let's move on and we will see. Okay. Today we have only one class with you. Yes, yesterday you had two classes. Division one had one class. Today you have one class. They have two classes. Okay, so let's move on. Regarding the attendance, we do not have to worry, I guess. Almost everyone is present. Uh, Let me see just. Okay, we have so many members. Let's move on to the topic. Yesterday we were talking about longitudinal framing, if I'm not mistaken. We were looking at the diagram, which is when some people had some questions, and we discussed that we will take up the questions in today's class. That is what we were doing, right? Let me see that. Mm-mm. Okay, so let me open this. Share it up, and I will. Okay. So this is where we were in the previous class. Uh, Actually, I should not have started this in the previous class because we ended midway. I think we were discussing about bulkhead and how the and why the stiffeners on the bulkhead are facing down. Am I right? That is where we were now.
Yes, sir.
Yes,
Or
sir.
do you want me to start from the beginning? Anything?
No, sir.
Okay. Then in that case, we will continue from there itself. Now the thing is, mm, okay, have I I've not shown you a picture of it. No? I will show you a picture today. Wait, there it will be better. So in this, we saw that we have the bottom, we have the longitudinals, we have the center girder, we have side girders, but by now we already know that side girders are intercostal in nature. So we can also refer to them as intercostal side girders. Once we have that, we have fixed longitudinal bulkheads. On the longitudinal bulkheads, we have stiffeners facing downward because we understood that this is a oil tanker. And in the oil tanker, there can be accumulation of cargo in these crevices, which is why we are taking extra precaution and we are keeping the stiffeners facing downwards. Now, once that is done, we already know that there's something exists called as racking. So the remedy to racking is we provide some transverse stiffening members or some transverse framing members. Now on this side, we do not see any transverse member, does not mean we have not added it. Basically means the cross section, wherever it has been taken, at that particular cross section, there was no transverse member here. There was a transverse member on this side. Okay. This basically means like we have a transverse member here. The transverse member is like this actually. The transverse member is taking support from this girder and it is connected to, always remember when we have transverse members like this, intermediate short transverse members, they will be connected to some stiffener always. You don't keep it connected to halfway between. It will be starting from a strength member. It will take support from a strength member and it will be terminating at a point where we have a stiffener. Okay, if you try to draw this in the exam, pay attention to this. Do not end these transverse members somewhere where there is no stiffener. Okay, it affects the strength aspect of it. We have a bottom transverse, we have a deck transverse, and we have a transverse member in between. The reason we have such kind of a typical arrangement is that it is not mandatory to have such a design. You can have different kind of transverse members also. Okay, before we move on, let me show you a picture where we will be able to better appreciate the kind of structures that we have talked about. Okay, let me find out. Just a minute. I have it somewhere. I need to open that. Okay, I got one. Let me show this to you. I will share screen of this file. Okay. Is this picture visible to you now?
Yes, sir.
Okay. Now, in this, try to connect whatever we have seen in that particular picture with this. The transverse member, which was shown there, is something like this. Imagine just this side shell. Just try to imagine this side shell as a straight bulkhead. If we imagine that side shell as a straight bulkhead, then this transverse member, this is a transverse member. From the side shell, it has moved on to the deck. We can have different types of connections also where we have a transverse member connecting only the side shell. Then we have a transverse member under the deck and we connect them using a bracket. Okay. But in this case, they have taken the transverse member continuous from the side shell under the deck. Okay. Now, this is a typical case. Let me show you. See, this is a transverse member passing. Okay, and we have longitudinals also passing, the deck longitudinals which we saw in the picture. So how do they pass through each other? They pass through each other. This we will see in a different unit, but since I have opened the picture, I'm showing you. The transverse members will have openings in them. Okay, these openings are called as scallops. Okay, what other things we can notice here? See, in this structure, can you see my mouse pointer?
Yes, sir.
Okay, so this is the deck.
Yes, sir.
Okay, so this is the deck. Okay, and these little ones, I will zoom in. These little ones are the deck longitudinals, and the seeing deck. Okay, similarly for this deck, this is a girder. Now this was a defense class vessel, so it has different requirements. It does not have cargo holds, so it has a slightly different design, but the structural arrangements are okay. And you can see the transverse members. See, this is a bulkhead. Okay, this is a bulkhead. This was supposed to be a compartment called as airlock. Uh, See, this is our vertical center girder, okay, which we have shown, and this section is towards the forward side of the ship, which is why you see the bottom is too sharp. Okay, towards the midship, the section will be slightly wider. Okay, so this what you are seeing here is the girder, and this is our tank top. Is it clear? Do you want to ask any question from this picture that you are not getting? This is the deck girder. Okay. Any questions on this? You want me to show any particular location in this?
No, sir.
Okay. Okay. One more thing I should say you. Always remember that when we have this, suppose we have an arrangement like this. We have a transverse member and the longitudinals are passing through it. Merely having this arrangement is not enough. As we have already discussed, we need to strengthen the components, that is the side shell, the deck, but we have to ensure we have connections between them. So this, if you notice, you will see that there is some plate kind of thing visible here, slightly, not clearly, but slightly it is visible. That means we have a plate which is connecting this transverse member onto the longitudinal member. Okay, we have that. See here also you can see there is no gap. We have connected. This was a block under construction and I took a photo. So everything was not complete, but you can see many details in this also. Okay. So we have such connections. We'll come to that when we talk about bottom structure in the next unit. Okay. So this is about it. Okay. Should I close this photo? No questions then?
No questions, sir.
Oh, I will stop this. Just a minute. Okay, this is what. Let me come back to this. Okay. Just okay. So in this, now I hope you are better able to visualize structure now. You have seen the longitudinals, bulkheads, side shell, deck girders, bottom girders, center girder. Is it okay now? Is there any question anywhere?
No, sir. Clear.
Okay. So let's move a little forward. Now, this longitudinal framing of this many girders, this is a approximate representation of it. We have a lot many girders. That means we have lot many longitudinal members. Okay, and to that we add quite a few transverse members. Okay, when number of transverse member is less, that means these will all not be whole frames kind of thing. They'll be web frames. They'll be bigger in size because they are lesser in numbers. Okay, always remember this ring kind of structure will be there in all types of ship. Unless you have this ring kind of structure, you cannot arrest the racking forces. Okay, so this ring kind of structure will always be there, and in this case you have been shown the side brackets. We will also have brackets coming from this longitudinal to the transverse frame also. Okay, which will be the beam knees. Though they are connecting the longitudinal member to the transverse, it will be referred to as the beam knees. Okay, so this is a typical representation of a longitudinally. Now, what all differences did you find in transverse framing system and longitudinal framing system? Can you point out a few differences between them? At least a few, just general observation. You must have noticed some observations, isn't it?
The transverse panel is vertical.
Transverse is central. Longitudinals are the vertical members, true, yes. Transverse member are like circular kind of thing you're referring to it, is it?
Yes.
Okay, yes. The transverse member are a ring kind of thing. Yes, please ask.
So is the transverse framing system more spacious?
We discussed about it now. In case of
Yes.
transverse framing system, we have more
Yes.
bale capacity. Yes, and the very good point that you have said. So we have more bale capacity here. Let's see. Okay, we have more bale capacity. Yes. Now this ring kind of structure, it is there. Whether it is in transverse system or longitudinal framing system, we have that ring, that floor, the side shell transverse and the deck transverse. They will be present. Only thing is the quantity of it is more in case of transverse framing system. Okay, and the quantity of longitudinals is more in case of longitudinal framing system. Now that we have understood this particular thing, that the bale capacity is more for transverse framing system, let's try to elaborate it. Let me see what I've kept. There's a video here. When I played that video for a few moments, were you able to listen to the audio?
No, sir.
Achha, the audio has to be fixed somehow, because I'm sharing my screen only with the computer. I'm not sharing this audio with it. Okay, that video is not that good also. I will provide you a link to that video and you can probably watch it later. Okay, we can do that way. We will move on with our topics, and you watch that video later on. Okay. So I'm just skipping this video as of now. Move on. Acha, हाँ. So for transverse framing, yes, most we can use vessels, longitudinal for longer vessels, and more bale capacity for transverse framing. And longitudinal framing, we are having this lesser bale capacity. The third kind of category, that is the combination framing system, it originates from this particular problem of reduced bale capacity. When we are making a ship, we always have to remember why we are making it in the first place. We are making it because we want to kind of carry cargo, or you can say that we want to make money out. Money is the basis of all business. So we saw that if we have a liming arrangement, and if we have a short structure, we do not need longitudinal, so we are avoiding it. But if we have a long, not reduce our bale capacity, we want to carry more cargo. For such a condition, or for such a situation, this combination framing system came into picture. What it does is it implements longitudinal structure or longitudinal framing in the double bottom and under the deck, because those are the long plates that need the longitudinal string. Okay, and for the cargo space, wherever we are keeping the cargo, there we will be making use of transverse framing system. So in this way, what we have done is we have taken care of the longitudinal strength that is required because the long slender plates are the bottom plate and the deck. So the bottom and the deck, we have done longitudinal framing on them, and transverse framing has been utilized for the side shell. This way, we have taken care of the longitudinal strength, and we have taken care of carrying capacity of the ship as well. This kind of arrangement you will find in case of large merchant vessels, not for the small ones, okay, or the intermediate ones. Let's see what we have there. Now this represents a combination framing system. Anyone? Any guess what kind of a ship it is?
General cargo.
Yes, general cargo ship. We have a twin deck here. Now, notice how it has been made. We have a bottom plating. We have the side shell and the deck. Broadly speaking, if you notice, we have stiffened the bottom structure longitudinally because we have those bottom longitudinals, inner bottom longitudinals. We have the center girder, we have the side girder. And below the deck also, we have a similar arrangement. We have longitudinals, we have the deck transverses. You know, you will be able to visualize how we have the transverse and longitudinal members in the same place. That means you have already seen that we have allow for the passage of longitudinal members through the transverse members. Clear?
Yes, sir.
Yes, sir.
Okay. And also, we have also seen that, let me show you this. So if I try to show this particular section, if I try to show you an expanded view of this, it will be something like this. We have the plate and we have a stiffener, but the transverse plate around it, or the floor that is passing, it will have a opening like this. Okay, this opening is called as a scallop. Means the floor, when we have made this floor was built or it was cut in such a manner that it had a scallop. Okay, and merely this kind of design is very efficient because we do not have a connection between the transverse plate, that is the floor, and this longitude. What we will do is we will add a small plate in this manner. We will add a plate in this manner. This little plate is called as a collar plate. And this collar plate makes a connection between the longitudinal and the transverse member. And this is applicable to all plates under the deck also. One more thing that I should have told us, notice they have shown some holes here. They have not shown those holes here. What is the reason for that? Now, the double bottom of a ship is utilized for carrying different types of liquids. Sometimes the double bottom, or sometimes the floor that we are representing, it may form the boundary of a tank. Okay, so as you can imagine, when the double bottom, when the floor is forming the boundary of a tank or the periphery of a tank, it cannot have any openings on it. Otherwise, how will it form the boundary of a tank? In that case, we will not have any of scallops or colloids also. The longitudinals will have to get terminated there. In the picture that I showed, it was visible. I did not speak up. Do you want me to show you an example of that in the picture?
Yes, sir.
Okay, let me show you that. Then we will come to it. Wait. Okay, it is there. It is there. Let me show you. Share screen. Here, we will not talk about the bottom here. The logic is same. Let's talk about this part, or maybe this part. Anyway, देखिए यहाँ पे, here you see the longitudinals are passing through the transverse member. They have scallops made for them. Okay, but when you look at this particular place, in this place, is something important. Maybe a high risk, a high fire risk zone, maybe on the other side of this bulkhead, which is why we have not made penetrations on this transverse bulkhead. Okay, instead you see these longitudinals are getting terminated there. See here also. We do not have openings. We have filled it. Here we have openings. Okay, is it clear?
Yes, sir.
Yes.
So, for floors also, whenever the floor is not forming a boundary, it can have openings, can have scallops and everything into it. But if the floor is forming a boundary, then in that case, it will not have any of those openings. It will be a solid one. And because I'm saying this, floor is of this type, a solid one. It has no openings in this. It forms the boundaries. It is called as a solid floor. And whenever that solid floor, it has only a few openings, like for scallops or those circular manholes kind of, it will be called as a plate floor. But you do not have to remember that now. It is a topic for the next unit. Okay. The problem is topic in isolation. You cannot say that you will study only deck and you will not bother about the other members, because some way the concepts deck and bottom side they are interconnected. So that is why I'm introducing new topics, but at the same time, when we talk about that one, the bottom tanks and structures, that is when we will start talking about different types of floors. There are three different types of floors. The third one is visible here. So if I tell you, here also the collar plate, the little plate that is connected from the longitudinal to the transverse one. Okay, and as you can see, the vertical center girder has also some stiffeners added to it. Okay, so that's it. I will stop here.
No, sir.
I mean, will you be more comfortable if I stop asking you any questions or not, and you ask whenever you have, or do you prefer me asking you?
No, sir. It'll be better
Understand?
this way. It'll be an interactive session.
Okay, it will be better if I don't ask you you have any doubts or not, right?
No, sir. It'll be better if you.
Okay, okay. Then that is what I will also prefer, because okay. So that's it about the structural aspect. Okay. Yes, just a minute. Most people is on. Please mute yourself. Yes, thank you. So just a minute. Yes. This thing is also there included. One thing I forgot to tell you that day is this. Let me come to it. Let me come to it. Yesterday, I thought it's not syllabus, but it is. When we talk about beams, it's a simple thing. When we talk transverse members, the little ones, the beams, and they are connected to the shell transverses using the beams. Can have a slightly remixed name kind of thing, let's say. The reason is deck beam. Suppose I have a deck, I'm seeing from the plan view. I can have two different types of beams. I mean, the same beam, same size, same thickness. We are not changing its dimension. It can be like this. But sometimes we may have a hatch opening. If I have a hatch opening, the thing is I cannot take the deck beam from side to side. So now my deck beam will be kind of terminated at the hatch side guard. Is it clear?
Yes, sir.
Yes. Now, in such a case, the deck beam will be referred to as a half beam. We are not taking its length to be half, so we are taking half beam. But if it is getting terminated somewhere on the way because of the presence of a hatch, we refer to it as a half beam. Is it clear? यहाँ तक आया ना?
Yes, sir.
Okay. So we have discussed about transverse framing system. We have discussed about longitudinal framing system. We have tried to compare it. We have discussed beams. We have discussed half beams. We have discussed about side brackets. We have discussed about beam knees. All these topics, do you have any confusion anywhere? Because it has a lot of new definitions and terminologies. Anything that you want me to speak about? No? Okay. Now, let's move on and I will I will add a few more definitions because so far you have been able to grasp them. This is a example of combination framing. Okay. We have longitudinal framing for the bottom and the deck, and in the cargo hold region, we have transverse framing. So we have taken care of the strength aspect because we have a long vessel. We have done longitudinal framing, and you can notice that in the cargo hold region, we do not have any longitudinal spacing. And here, the transverse region has also been appropriately shown. That is, we have quite a few hold frames and we have web frames at some intervals. Now, also remember the way we are saying they are of smaller physical dimensions. Those physical dimensions of structural element have a name attached to it. It is called as scantling. Arey bhai, who is that? I mean, mute yourself, man. You all are in campus or at your homes?
Campus, sir.
So campus
Acha, you have your roommate with you
H3.
then.
Yes.
Yes, sir.
That is why. So, yeah. So it is scantling. When we talk about the physical dimensions of any member, we refer to it as the scantling. So I can say that the web frames are of greater scantling. The hold frames are of lesser scantling. Okay, this is one more. We will come to this also. in some other unit, I believe. Okay, that is when we will talk more about the Scantling details. So, with this, again, just to revise, remember we have a ring kind of structures. Okay, for the ring kind of structures, the transverse member in the bottom is called as a floor. The transverse member in the side shell, they can be hold frames, they can be web frames, or web frames. They all collectively can be called as transverse frames or side shell frames. Okay. Under the deck, we have deck beams, and the bigger members, they'll be called as deck transverses. Okay, let me just write it. Deck beams. Transverses have not been shown. I'm not showing. The bottom structure is connected to the side stiffening members using the tank side brackets. And the transverse frames we connect to the deck longitudinal. Is it clear so far? Also, always remember that these floors, wherever the center goes, if this is the center, okay, यहाँ पे लिख रहा था क्या? हाँ. The floors will be kept continuous from center girder to side shell. So essentially, these side girders will be disconnected at every floor. And because of this property only, we are calling the side girders as intercoastal side girders. Clear so far? मैं डिस्कनेक्ट हो गया क्या? आ गया मैं. How to do? अरे I'm there. Are you all there? Okay. I hope you are not saying anything. I thought I got disconnected. Okay. So this is about this thing. Any questions so far? No?